Periodic functions. Periodic functions have values, and they correspond to the independent variable, but they repeat at equal intervals. Okay? So for instance, I have a graph of a Ferris wheel, and this graph relates the height of the Ferris wheel over time. Okay? Now we know that a Ferris wheel normally is what shape?
Square.
Good. Okay. We have a Ferris wheel. What we're going to do is we're going to actually try to figure out the information about this Ferris wheel from the graph we have here. Now, first of all, this is a periodic function because it repeats. Okay? It has what's called a peak and a trough, or as you guys may think of them as a max and a minimum.
Oh, I remember.
Okay? That happen at the same level. And in fact, what is the max level of this Ferris wheel? That's right. 5 meters above the ground, which is really low, so we're going to say in tens of meters.
50 meters.
So it's a little better, yeah. So now it's in 50 meters, okay? So it's in tens of meters. And what is the lowest point of this Ferris wheel?
0.
Ground level. Okay? I'm going to say it hits the ground, just at the tangent to the ground there. So, we have a Ferris wheel here, and it has a repeating pattern. How long does it take for you to get to the same point you started? So for instance, where do we start on this Ferris wheel? How high in the air are we when we start?
0.
0, that makes sense. And that time is also 0. The Ferris wheel hasn't started yet. That's where we get onto the Ferris wheel. It then goes up to how high? 50 meters. How long does it take? How long? 20 seconds. Because this is in tens of seconds, it takes 20 seconds to get to the top of this Ferris wheel. Okay? And then how long to come back to where we started?
20 seconds.
Yeah, from when we started, or 20 seconds from the top, you could say. Okay? So, let's relate this to a Ferris wheel to start. If this is the ground, what color I want? Yep. So here's the ground. Ferris wheel just touches the ground. Okay? 0. Don't worry, it's been engraved into the ground. We'll call it sea level. The highest point of this Ferris wheel happens to be 50 meters above the ground. Okay? So we know that this total height here is 50 meters. We know we start here. Okay? Because there's a circle, it's going to repeat the exact same pattern over and over time. So we're going to try to relate this. How long does it take for it to get to the top, we said?
2 seconds. 20 seconds.
20 seconds, right? It's in tens of seconds. So it takes 20 seconds for us to go from here all the way around this circle. Okay? This is a 20-second interval. And then how long does it take for us to get right back to the beginning again? Another 20 seconds, or 40 from when we started, right? So it comes back around to 40 seconds. What if I were to say to get halfway up? So if I wanted to know how long it takes for you to get to 25 meters, halfway up, how long would it say?
10 seconds.
10 seconds, right? It would take half of the time to get to 20. Or it would take 30 seconds, because on the way back down, we also hit 25. Okay? And that makes sense. If we were to draw a line through the middle of this, the middle of this would be at 2.5. Okay? 2.5 would be the middle of this Ferris wheel. We know that. Which also means that's probably where the axle of the Ferris wheel is. We're just kind of drawing extra information. You don't have to know this all to start. That would be the center of this circle. So the middle of this, and as we get into a sine function, this is also called the equation of the axis. We have our max, and we also have our min. They're also called peaks and troughs. Okay? Peak, that's R shouldn't be there, and the trough. That's our lowest point. Okay? This is a repeating pattern. And what we really want to know is the period of this periodic function. A period is how long it takes for an entire cycle to go through. So to go from one starting point back to that same starting point. How long did a period take in this case? To go from the starting and get back there?
40 seconds.
That's right. It took 40 seconds. That's how long it took for us to start at the ground and get back again to the ground. So the period of this function is 40 seconds long. That's part of what we just discovered. Okay, this is 40 seconds long. Excellent. So we've got that. What is the range of this Ferris wheel? From the bottom to the top, how long is it? That's right, good. So this is the range of the object. That's our 50 meters. Or in other words, from here to here, this is the range, which was 50 meters. The period was 40 seconds, which means another 40 seconds we should get right back to that same spot again, which we do at 80. So it takes another 40 seconds. Now, I want to know how many cycles this goes through, this Ferris wheel. How many times does it go around? Twice, that's right. This has 2 cycles. Okay? Cycles you could consider as periods. So you could say the period of this is 2 cycles. It takes 2 cycles to actually finish this ride. It ends at 80 seconds. Okay? And final thing, from our equation of the axis, we're going to focus on it tomorrow. I just want to bring it to your attention today. There's something called the amplitude. And the amplitude is from going from the middle of the equation of the axis to the top or the bottom. The distance should be the same. Okay? Does anyone know what the amplitude would be in this case?
5 and...
You go to 0 to 50, but the amplitude is from the middle to the top or the middle to the bottom. How far is it from the middle to the top? 25. Good. It's only 25. Okay, so our amplitude is 25 meters from the middle up and down. Okay? So, we've gone through a lot of information. Of course, this is the amplitude here from the center of the Ferris wheel. So, with this periodic function, essentially I've shown you how this periodic function relates to a circle. Okay? It's very similar to a circle, but we've elongated it. Because time is linear, okay? Time doesn't come back. We don't start at the beginning of the day and then end again at the beginning of the day. Okay? Because time is linear, we represent it in a straight line form. Okay? So these are representing a circle, us traveling in a circle several times, around and around and around. So we've gone through a lot of information. A lot of it is we're going to focus on again tomorrow. Really what we do want to go is a couple of these definitions, and you want to be able to recognize a periodic function. Okay? So I'm going to add a little to this. The second part of this is going to be very simple, okay?
So isn't there a formula for a period?
Yeah, we're going to get into that tomorrow. Okay? Doing a couple more. This part should be a lot easier. Okay? I guess we should pause this part. Okay, I have 4 graphs up here. And really what we're going to be looking at is whether something is periodic or not. Okay? The very first one we have up here.
Nah.
Is this periodic or is it not?
No.
How many say yes, Bertrand?
That's right.
How many say no? Why not?
Because it's not constant. It's changing.
Okay, so our max and our minimum intervals are changing. Okay? Getting larger and larger and larger. This is not a periodic function. It needs to repeat the same pattern over and over again. Okay? Even though it looks like it's going up and down, because the amount is going up and down by, does not make it a periodic function. Good. So this is not a periodic function. How about our second one here? Is it a periodic function? Hands up for yes?
Yeah.
Hands up for no? Okay, most people said yes. Why is it?
Because it's constant and it's repeating.
We're repeating the exact same pattern over and over again. It doesn't matter that it has a wave to it. It is periodic. It looks like it goes 2 across. Takes a second to come up to 3. 2 across again. I didn't draw that well, eh? Takes a second to come down. 2 across. Takes a second to come up. 2 across. Second to go down. So yes, this is a periodic function. How about our third function here? Possibly? Let's go through it.
Yes, it is.
It takes 2 to go across at 1. And then it drops, takes a second to come all the way down to -7. Takes a second to come across again. Another second to come up to -3. 2 more seconds flat, back up to 1. Okay? And then it actually repeats that exact same pattern. So it might not be extremely easy to recognize the period of the function,
But yes, it is.
but this is a periodic function. It is repeating the same pattern. The period, it looks like, is taking from, 10 to -2. So it's taking about 8 seconds to repeat this period. Okay? And it goes through many different things, but the cycle is the same. Okay? It still only has 1 max, 1 min, but it stops at certain points. And finally, the last one, is this periodic? Is this a periodic function?
No.
Why not? What does that mean if you circle? It's just a function. Why is this not a function? Doesn't pass vertical line test. Okay? It does look very repeating in terms of what it is, but this does not pass the vertical line test. So no, this is not a function. Okay?